All right, everybody, we are back this week to take a super quick walk down a whole bunch of definitions. So brace yourself. Definitions are coming. Keep in mind the content from the previous video I posted. Remember that statistics is a bit like a foreign language. It might take some time before some of these concepts are coming naturally to you, but continue to go with it. Give yourself the time you need to practice applying this content with this week's homework and beyond. Give yourself time and the information will sink in. So if it feels a little bit overwhelming all at once here right now, that doesn't mean that you won't understand this eventually. Just look for the stuff that does register right now. Take notes on the stuff that you struggle with right now. Know that we'll be revisiting these concepts as we continue through the course. So we are going to talk about quite a few things. Luckily, they interconnect and are relevant to one another, so we will build as we go. Okay. So we're going to come back and talk a little bit more about descriptive and inferential statistics. Essentially, descriptive statistics are describing a data set. Inferential statistics are making inferences, are making assumptions based on a data set. So we'll come back to that because it's important for us to understand populations and samples as we think about descriptive and inferential statistics. So this is a helpful image to think about populations and samples, as the image suggests, a sample is just a smaller subset within a larger population. So for example, if I wanted to do a research study involving students at UNO, the population of that study would be targeting all students at UNO. However, when we think about trying to measure a population, how realistic is it for me to assume that I'm going to be able to get every single student at UNO to participate in a survey, to respond to some sort of request for data? How realistic is it that I'm going to get information on every single student at UNO? Maybe I can, yes, and if so, great, I can continue with my study. If not, I might need to think about using a sample. So a sample is a way of reflecting a larger population. However, a sample is focused on a smaller subgroup within that population. So a sample within the population of all students at UNO might be the 25 students I happen to find at Milo Bale Student Center who are sitting there as I'm walking through the building. Similarly, maybe I'm interested in doing some sort of study or finding some sort of information out about the experiences of a student of statistics. By population would be all statistics students across the potentially state of Nebraska or United States in general. Again, very unlikely that I'm going to be able to get access to every single member of that population. Instead, I'm probably going to be working with information from a sample, such as all the students in this course. So I can use the sample information as a way of learning more about the population. That's where we're getting into descriptive and inferential statistics. Again, I'll have another slide in a couple moments to tie some of those pieces in, because I want to give one more example of how an actual survey does measure at a population level. Most often we find that we're not able to access the full population and we have to instead rely on that sample population or that sample subset within the population. On some occasions, we might be able to access the full populations. So a couple of actual real-world survey examples that either rely on a population or rely on a sample, a smaller group of the population, would be the U.S. Census, and opposed to something like the American Community Survey. So the U.S. Census, this is timely as we are in the process of having this process play out again for us as the United States. The U.S. Census is the one way that we really do collect information on ideally every person living in the United States at a particular point in time. The American Community Survey is a much smaller survey that is done on a sample level instead of trying to target every single person living in the United States, which, as you can imagine, is no easy feat. All right, a couple pieces of information. You don't need to know this information for the context of this class, but it's important to just know in general because all of you will be asked to. Well, you've likely already been asked to participate in the census. So this is something that dates back to our U.S. Constitution. This is actually written into our U.S. Constitution. We've had censi being collected here in the United States since 1790 as a way of tracking our population. So it really is a population count as a purpose. However, much like the previous video, We see statistics being used to guide policy decisions as well. So, in fact, the census is kind of a big deal because it sets up who our representatives are on a federal level and who's making decisions for us in Congress and politics. So, the way that a state counts the number of people who live in that state can really have a big outcome on how they're being represented. So, a smaller state like Nebraska, for example, is going to, because our size of the state is smaller, we're going to have fewer representatives on a federal level than a state like California, for example, with a much larger population. So the US Census is a big deal because it dictates what states get to have their voices heard more effectively, more impactfully at a federal level when laws are being created, when decisions are being made. So the US Census asks us for some basic information, basic demographic information. Indeed, every person is required to participate. If you are ignoring your census invitations, they will have someone call you instead. I don't know that they'll be doing that this time around, but they will also have people go and visit your house if you are not responding to the census because it is mandated by law. Officially, you can be fined if you don't participate. It's something that's collected every 10 years. So 2020, we have another census happening for this particular decade. Post American Community Survey, which is a survey that is used for business decisions, local decisions. It is a survey that is used for some of these bigger political decisions, not quite like the census though. It's more of some of those like more minor decision-making processes about how to allocate money, what to expect what to expect in terms of how much consumers are going to spend or not going to spend. A lot of our economic outcomes come out of the American Community Survey. So this is something that's implemented every year. It hasn't been an incredibly long amount of time. It asks for more information than the census because it's interested in more information than just the census. Because of that, it also uses a sample structure instead of everybody being required to participate. So the US Census, kind of a big deal to get, 300 plus million people to respond to a survey. Not an easy thing. It can be hard to even get 10 people to respond to a survey. The American Community Survey uses a smaller sample of households instead of trying to replicate this massive survey every single year because they want to keep more of an updated understanding of what's happening, what's going on with our economy, what are people spending, how are people living, how's our health, etc. They ask more frequently. They're administering the survey every year. It would definitely not be realistic to ask the same people to participate in the survey every year. We would be exhausted. Once every 10 years is enough to participate in the census if you've been alive and around long enough to deal with that. So with the American Community Survey, a different sample is collected each time. So they're asking a different set of people through very statistically designed processes of deciding who's going to participate. They're asking different sets of people to participate every single time. So they're getting kind of like a broader range of data. They're able to see some patterns and ebbs and flows in a way that the US Census isn't. Although at the same time, the not so helpful part about the American Community Survey is that it is based on a sample. So if the folks who happen to participate are somehow skewed or aren't reflective of all Americans living in this country, we might end up with false information. We might end up with some false data. So here are copies of the Census 2020. If you haven't yet seen this, again, it asks very simple information about who's living in this house, what is their gender, what is their age, what is their race, just trying to track some of the basics of demographics, as opposed to this page from the American Community Survey, which is asking about things like, does your house have hot and cold running water? Do you have a stove or a range? Do you have a fridge? Are you able to make phone calls, etc.? So a little bit more depth of information. That's why they want to do this survey every year instead of every 10 years. Also why they're using a sample and not a population. So this brings us right into descriptive and inferential statistics. That's what we're already talking about if you can't tell yet. Descriptive statistics are describing a sample. So if I have all of the information, if I have every single person's response and I'm simply looking at their responses and doing data analyses with their responses and reporting out, here's what their responses were, I'm practicing descriptive statistics. So if I'm working with a sample, I'm usually always practicing descriptive statistics. The US Census is an example of how this could be applied at a population level too, though. So the US Census is still descriptive statistics, but it's operating at a population level because it's one of those really rare situations where we were able to ask our whole population to participate. So the US Census is a bit of an outlier on its own in that we're able to use it for descriptive statistics. Most often, if we're trying to look at information, especially in a bigger way, we're going to have to rely on inferential statistics. So inferential statistics come about, this process happens when we take a sample, so we take the social work students' survey results from this class or whatever, and I'm trying to apply that and generalize that to a much broader population. That's when we're moving into inferential statistics. We're taking this sample, I'm looking at this sample, and then I'm using these fancy statistical processes that we'll learn in the latter half of the semester to broaden those results and essentially apply them to the broader population in recognition that I'm not going to be able to survey every single statistics student, so instead I'm going to have to settle for a sample. I should have added I include dictionary definitions of a lot of these terms on the screen. With statistics, I can find that we can get really bogged down in the definitions and like, what does this mean and how does this apply? When in doubt, look at the dictionary definition. So if we look at the dictionary definition of descriptive, it tells us serving or seeking to describe. We're not making any kind of judgments. I'm only reporting to you what's here. If I had 5 people participate in my survey, I'm giving you information exactly as those 5 people reported it to be. Here's information reflecting the 5 people who took my survey. There you go. Descriptive statistics. On the other hand, inferential, the definition is characterized by or involving conclusions reached on the basis of evidence and reasoning. So here we are making inferences, we're making some assumptions, we're taking some leaps in judgment. Statistics is all about probability, it's about estimation, it's about making the best choice possible. That's what inferential statistics is doing. It's taking, maybe I had 5 social work statistics students, and I'm using their results to try and generalize much broader. That's going to be really difficult to do because I'm only working with 5 people and I'm trying to generalize that to a much broader population. So descriptive statistics is a really straightforward process. With inferential statistics, we're making assumptions, we're adding pieces of information. This is where it's easy to get things a little bit tricky. So we have to be really careful about how we are using a smaller sample to make inferences about a larger population. So the American Community Survey is a great real-life example of this. As I mentioned earlier, the US Census is already descriptive statistics because it is one of the only, I think it's the only survey that's a nationwide survey that every single person in the United States is asked to respond to that. That's a very rare situation. Most often we see examples like the American Community Survey where we're having a much smaller sample, we're having a much smaller group within the population. We're applying statistics, we're doing the fancy statistical calculations, and we're generalizing those results more broadly outwards. We're expanding those results to apply to all residents of the United States. So we will be coming back to those terms for sure. And we have to ask ourselves the question here when we're talking about inferring data, when we're talking about describing data, what are we even describing? How do we even decide what it is that we want to see, what we want to measure? In the American Community Survey, it's not just a random survey with a bunch of random questions that people wrote and put together. It was a very strategic, intentional process of what do we really need to know about the United States population? What do we need to know about our economic situation? What do we need to know about people's health and wellness and housing situations? So when we're talking about descriptive and inferential statistics, super duper duper important to, of course, first decide what is it that we want to describe or infer. And this is where variables and constructs come into play. So a couple more definitions to throw at you. Variables and constructs, very similar. Variables and constructs go together, just slightly different ways of thinking about the thing that we want to learn about. Okay, so if we look at this definition of a variable is not consistent or having a fixed pattern, liable to change. Essentially, that means it's a particular characteristic that varies between people, that changes between people. It's not something all of us share identically. Therefore, it's interesting. It's something that we're interested in actually measuring. The variable is very broad. It's essentially a characteristic that varies. It's something that we're interested in studying. Probably anything you can think about that you'd be interested in studying is going to be something that varies. Something that wouldn't be variable is like, are you a human? Right? Like all people are humans. We don't need a survey question to ask that because that's a constant, that's fixed, that's not going to change, that's not going to vary or differ between any of us. Our race differs, right? My race is different than some of your races. My gender is different than some of your genders. My age, housing status, etc. So when we're talking about something that's different between people that we want to look at, we're talking about a variable. Variables pretty much everything. So it's really similar to a construct. A construct is made up of different conceptual elements. So if you look at the definition here, it's something that's brought together various conceptual elements, typically over a period of time. It's a construction of something, right? If we look at this house over here, we know it's a house, but it's a house that's been constructed, right? Like a house is made up of different parts, and that's how we know it's a house altogether. A room isn't a house, a roof isn't a house, a window isn't a house, but all those things together are what create the house, right? A construct is a slightly more complicated variable that isn't quite so straightforward and easy to measure. Something like age, something like race, something like height or educational attainment, those are really standard, straightforward things that we as a society have very clearly defined. We know how to measure that. What's your educational level? You know how to answer that question, right? There are some things that are a little bit less easy to understand. If I asked you to assess your well-being, what is your well-being right now? What do I mean by that, right? How satisfied are you with the experience you're having in college right now? It's a little bit more complicated, right? There's not an easy, straightforward answer to those types of questions. So variables are much more clear, straightforward, super simple data points that we look at that we would be interested in measuring, assessing, analyzing, reporting. Constructs are essentially the same as variables. It's just like a more complicated version of a variable that we might have to think a little bit more critically about. What do I mean by this? So that way I'm not asking a survey. If I ask 5 of you to tell me what's your personality type, you're going to give me 5 different answers depending on how you interpret that question. If I want to construct this, if I want to do a research study on this, I'm going to have to figure out, how do I define personality type? What are some examples of that? How do I want my survey participants to actually answer that question? That's what calls on me to put together the pieces of the house and figure out what makes up someone's personality type. What makes up satisfaction with something? What makes up our well-being subjectively? That leads us into conceptualizing and operationalizing. So these two terms are essentially applied to how we are thinking about our variables and constructs and how we're collecting information on those variables and constructs. Okay, so again, to start with these dictionary definitions, in case we get confused later on in the semester and need to do a Google real quick. Conceptualize means to form a concept or idea of something. Operationalize means to put into operation or use. So this gets at the previous example I was talking about. If we're working with something that is a little bit fuzzier, we have to be really clear about, how am I conceptualizing this? Even if I'm asking about race, there are different interpretations of what constitutes a race and what constitutes an ethnicity, and what race categories should be asked about and what race categories should be lumped together. There are differing opinions on that. So even if I want to ask us, even if I have a survey and I want to ask people, hey, what's your race? How do you identify in terms of your race? I still have to think through, how am I defining race? How do I want to break those categories up? How am I going to analyze and sort that data? That's when I'm conceptualizing this information. I'm thinking about, how do I envision this? How do I understand race? How am I defining it for the purposes of this study? So I can be really sure that the folks I'm involving in my study share that same common understanding. Okay, operationalizing we will touch on as well. But again, conceptualizing essentially is thinking about, what specifically is it that we want to measure? Operationalizing, how will we measure it? Example of why this matters. Let's say I have a research question, and my research question is, how many cups of coffee do students drink each week? I'm interested in collecting a survey. So what I would like for you to think about for a hot second is, how many cups of coffee did you drink last week? And I'm going to sip from my coffee while you think. Okay, so some of you might be having an easy answer to this question. Like, it might be easier for you to come up with an answer. Some of you might have some questions. So you might wonder, what do I mean by cup of coffee? Is it a teeny tiny little espresso cup like this one over here? Is it, I mean, this is a fairly normal, regular sized coffee mug, but I have some of those big ones too. So I have some that are double this size. So if I drink from a mug double this size one day and I drink from this mug the other day, have I had 3 cups of coffee or have I had 2 in that time period? So I would want to conceptualize, what do I mean by cup of coffee? Oh, I mean 8 ounces of liquid, roughly 8 ounces of liquid. Okay, now you understand what I'm asking about in terms of cups of coffee. Last week, what a week, huh? It's Tuesday. This is from, what's that show? So many of you are thinking of the answer right now. 30 Rock, right? Yeah, 30 Rock. Okay. So how we define as a week also varies, especially right now, especially in an online class, the days of the week can feel really funky. So am I talking about like Monday through Friday? How much coffee did you have? Or am I talking about Sunday to Sunday or Saturday to Sunday? Or how am I defining this time period? What is a week essentially? So the way that I conceptualize these terms and the way that I then ask the question of all of you, that's going to skew my answers, right? Like if I'm not being clear and I'm just asking, how many cups of coffee did you have last week? Some people might be telling me 3 when actually they had 7 cups of coffee because I'm not asking my question the right way. So this is where conceptualization comes into play. We have to be really clear about how we're defining these variables. And then the operationalizing piece comes in, making sure that I'm communicating that outward when I'm actually gathering that information. So conceptualizing is, how am I defining this for myself? Operationalizing is, how am I putting this into practice? So am I being really clear in the way that I'm collecting this information as to what I'm wanting, as to what I'm gathering? All right. Thinking of something like well-being is another good example of conceptualization. How do we want to define this? How will we define this? How do we define this? The way you would define well-being is different than how I would define well-being. I found this nice little image that I thought was a good example of, again, how a construct would come into play. So with the construct, I might need to be measuring the same thing in different ways. So maybe instead of just a one survey question, that would be operationalizing, what is your well-being? Maybe I need to have 5 instead to ask people about their physical well-being, their social well-being, their mental well-being, their emotional well-being, their spiritual well-being. I have to think differently about how I'm going to actually operationalize, how I'm going to actually measure this information based on how am I defining this information. All right, so when it comes to operationalization, big fancy word there. When it comes to operationalization, operationalizing our variables, we have a lot of different ways we can actually collect that information. Again, with this, we want to be thinking of, what do I need to ask here? So with well-being, I'm not just going to ask, what's your well-being? I need to be very intentional about, am I even asking about well-being in general at all? Maybe I just have 5 questions about these different dimensions, and then I'm going to combine them somehow and turn that into someone's well-being. We can think about how do we want to collect this information as well? In addition to the phrasing of the ask, is it something that I want to just do a survey on? Is it something that I want to do focus groups on, where I'm like meeting with small groups of people and getting their verbal responses to the questions we're talking about? Am I wanting to do structured interviews? Observation or field research are something that sociologists do a lot of in order to collect information. If I'm interested in people's like behavior patterns, like who pays most often in a restaurant, I could sit in a restaurant, camp out, and observe what's happening and watch like different tables, who's paying for their meals. I could observe people's interactions as a way of collecting information at some point in time. My partner was actually in a sociology class a couple years ago where the class was asked to sit somewhere in a public area and observe people's behavior patterns and see what they could identify based on gender behavior patterns. So looking at how different gendered people were interacting together, looking at how gender was influencing people's mannerisms, taking notes on that, kind of like a mole in society spying on people. So that would be structured observation field research. Again, sociologists use that quite a lot. Published measurement tools are another common way, especially when we're talking about constructs, because they can be a little bit trickier to measure. Published measurement tools are essentially surveys that have been crafted to measure some of those trickier constructs. So this is actually an example. This is the link on this slide. This is a book that I had previously that included a whole bunch of different survey tools for, as you can see, strength-based assessment and evaluation. So happiness and subjective well-being, for example, like how to measure happiness is a tricky thing. Let's just click on one randomly and see what happens. So here's a subjective happiness scale where it's 4 questions and people are asked to rate themselves on a scale. In general, I consider myself not a very happy person, all the way up to a very happy person. Compared to most of my peers, I consider myself less happy, more happy. And then essentially all those scores are being added up together, and there's a final cumulative happiness score that comes as a result. So sometimes we see constructs being measured in that sort of a way as well. We're not going to dig very much into, like, this is about all we're going to talk about in terms of how data, how measures are being collected. We're going to focus primarily on what do we do with the statistics after they come in, but it is important to know where we're getting statistics from. And these are the examples of where statistics ultimately come from. They come from assessments, they come from surveys, they come from measurement tools, they come from experiments, etc. So for our purposes, we want to be really mindful that it matters how variables and constructs are being conceptualized. It matters how they're being defined. And then it also matters how they're being operationalized. It matters how people are being informed when they're participating in the data collection process, how they're being informed about these items. It matters how the questions are asked. It matters the way that we use. It matters the structure that we use. If I'm using like a verbal survey instead of a written survey, all of those pieces ultimately work together to influence the data that we're going to collect. Sometimes in good ways, sometimes in not good ways. So when we talk about that, the type of measurement tool or process, this moves us into the concepts of reliability and validity. So we're going to talk about those, and we're going to talk about levels of measurement as well. Reliability and validity and the levels of measurement are things that, again, we won't spend a ton of time focusing on in this class, but they are things I would recommend you like add to your notes somewhere. All these definitions to just add to your notes somewhere, keep them on hand. They're terms that we'll come back to and use again. So it'll be helpful for you to just kind of have this in your knowledge bank. All right, reliability and validity. They talk about this in the book. I wanted to give a quick example because I know this is something that I've struggled to wrap my head around at times. And there's a helpful image that I think might help you kind of flesh out the differences a little bit too between reliability and validity. So first of all, let's go to those dictionary definitions. When we talk about reliable, the dictionary tells us, or Google at least tells us, that we are talking about something that is consistently good in quality or performance, able to be trusted. So consistency is what we're seeing as a key there. Validity, in order to be valid, something has to have a sound basis in logic or fact. So this has to be something that is validly reasonable, is validly logical. If we think about it, does it even make sense at all? We're getting into questions of validity. Essentially, reliability comes down to, is this thing that we're using to collect data consistently measuring? So is it giving us the same measure every single time? And then validity, on the other hand, is it measuring what it's actually supposed to measure? So here's an image that was helpful for me in thinking about this, and I'll have an example for us to think about as well. If something is both unreliable and unvalid, we can see like the dots are all over the place. So it's not consistently measuring anything. Some dots are measuring something over here. Some dots are measuring something over here. It's also not valid because it's not hitting the target at all. It's definitely not measuring what it's supposed to be measuring because it's not even, it's all like above the target. So it's pretty far off. If we look at this next one, it's unreliable because it's not consistently measuring. The dots are now literally all over the map, all over the place. However, if we looked at the center point, if we took the average, we'll talk about average more next time, but if we took the average and looked at the center point of those responses, it does end up averaging out. It does even out to eventually be in the middle of this target here. So if we took the average, it would be somewhere in the center point. So essentially, it's valid. It is kind of on average measuring what it's supposed to measure, but the answers are all over the board, not reliable. Over here, we see all the dots are grouped together. This is indeed reliable. However, it's not valid because, again, it's not hitting the mark. They're all measuring something similar, but they're not measuring what they're supposed to be measuring. And now finally, we see both reliability and validity. No matter how many times I administer this survey, people's responses are going to be pretty consistent in terms of what's being asked. They're not going to be all over the board like they were before. And it's also actually measuring what it's supposed to measure. Okay, so an example of how to think about this, if I had a pre-test and a post-test that was like this, and I've actually done this before in in-person classes. Here's my well-being assessment. How much sleep did you get last night? Is it raining outside right now? Did you eat donuts for breakfast this morning? And are you currently too hot, too cold, just right? Are you feeling sleepy, hungry, stressed, happy, other? Okay, so validity is a question here first. Do you think these questions are a good assessment of well-being? What do donuts have to do with well-being? I mean, there could be an argument there, but I think there's some strong validity questions. Is this even measuring well-being? I don't know. Is it raining outside? Doesn't really seem like a great question to ask for that. Nor does, did you eat donuts? When we look at the pre-test and the post-test, so say that I'm administering this at the beginning of class and then again at the end of class to see if people's well-being changed. What's wrong here? I mixed up the questions, right? Like some of the answer options changed. The are you feeling question kind of merged. Number 4 and number 5 merged at the end there. So now we have an issue of reliability because I'm not even asking the same questions in the same way on the post-test. So there's definitely not going to be reliability there. So here's an example of where we can go wrong with both validity and reliability, depending on how we're asking the questions and depending on how we even start to define the thing. So we're seeing issues in both conceptualization, because my tool is not valid. It's not measuring what it's supposed to measure because I haven't conceptualized what well-being is very well at all. And we're also seeing an issue with reliability. We're seeing an issue with how this is being operationalized because the way I'm operationalizing it is with a question, a survey that I screwed up the pre-test and the post-test and they don't even align up. So we're seeing issues coming in reliability and validity as a result of the way that I've conceptualized and operationalized this particular survey. Okay. Last thing we're going to touch on this week is the levels of measurement, so scales of variable measurement. So this chunk is a little bit less connected than to the previous content than all that content is connected with itself. So the levels of measurement, they're a way that we collect data. They don't influence things like reliability and validity, although they could. They're a little bit less connected to that. When we're talking about levels of measurement, this is more so kind of setting a tone for the types of ways that we'll be able to analyze information. So as you're thinking about levels of measurement, this is something we won't be practicing a lot with this week. We'll come back to it a bit next week. Just know that it's a little bit different from the previous content, a little bit more disconnected. However, where this is important, where these levels of measurement come into play is in how we're actually conducting our analyses. The levels of measurement, the ways that we're collecting information, this dictates the types of statistical processes we're going to be able to use after the point of data collection. So this is more so focused on after the point of data collection. How are we organizing and thinking about the data that we have collected? So there's essentially 4 levels of measurement for data. And we're going to walk through all of them super quickly. And then I have a few examples for you to do some thinking about in terms of can you figure out which level of measurement this data falls into. Nominal level measures, and I also have little images next to each of these words on the side of the screen. I didn't come up with those, but they help us to associate a little bit of what do these things mean, because these are words that we don't hear very often. Nominal, ordinal, interval, ratio, they're much less common. You can't do the same dictionary thing with those. So nominal level data is data that has no rhyme, no reason, no order. So if we're collecting information on variables and constructs like gender, race, favorite ice cream flavor, those are things we can't put in any kind of organized order. And we'll come back to why that matters. But those are things we can't put in any kind of organized order. No one thing is better than the other. I might have subjective opinions on what I think is the best ice cream flavor, but my subjective opinions are definitely not reflective of everybody's, right? So we can't put those things in a natural order. They don't go in a natural order. Ordinal level data is data that does have some sort of natural order. So Likert scale questions, for example, if you're asked how strongly do you agree or disagree with something, we can very clearly put that in an order. Strongly agree, agree, neutral, disagree, strongly disagree. We know what order they need to go into. Same with letter grades. Same with something like educational attainment. We know what order those things go into. Now, interval and ratio are very similar. Both of these are essentially numbers, hence the little scale you see here. Nominal, reflected in circles, no rhyme or reason. Ordinal is kind of like steps. We can put them in an order, but we don't necessarily know the specific differences between, say, strongly agree and agree. We can't measure that difference the same way that we can with interval ratio level data, which involves data where there is an order that we can specifically quantify. So dates, for example, right? Like I can clearly count how many days or how much time is between these two particular intervals. I can't do that with Likert scale questions. Even letter grades, like there's a range of what constitutes a letter grade of A and what constitutes a letter grade of B. So I don't know if someone is like 5 percentage points away from an A and a B. It's going to be different for every person. With dates, with temperature, with time, that's standardized, right? I can concretely measure the difference between those things. It's going to be the same every time I do that. Ratio level data, very similar to interval level data. In fact, we'll talk about those as kind of the same thing. Very rarely do people differentiate between those two things. Ratio level data is data that we can quantify that also has a meaningful zero. So something like date, like there is no zero date. There is zero temperature, but it doesn't mean that it doesn't mean the absence of temperature. So a 0 degree temperature doesn't mean that there is no temperature. It's just a scale because temperature scales from the positive into the negative. So the 0 there is not meaningful, whereas if someone has 0 height or 0 age, they don't have any height, they don't have any age. If someone has had 0 cups of coffee, they haven't had any coffee. So the 0 actually means 0 in those kinds of situations. Okay, so interval ratio, very, very similar. If it's a little murky, the differences between those two, that's totally okay. That's not something we need to know, especially right now. Just know that interval ratio level data, much like that little scale next to it suggests, is data that we can specifically measure the differences between numbers, essentially. If we're asking people to report numbers, we're working with interval or ratio level data. And how this matters, of course, well, not of course, but let me tell you now, how this matters is that it dictates how we analyze the data, as I was saying before. So we can't add or subtract or divide favorite ice cream flavors or gender or race. However, we can add up number of scoops, which would be ratio level data. So when we get into descriptive statistics next week, the types of calculations we're going to talk about next week are dictated by the types of data we're collecting. We're not going to be able to calculate what is someone's average gender because we can't do the same kinds of calculations with gender as we can with number of cups of coffee someone has had. Okay, so to end this presentation, let's do some thinking. Where do you think eye color fits into these levels of measurement? Where would you put eye color? What level of data is eye color? Hopefully you were thinking nominal level data. Can't put eye color in any order, right? Can't add or subtract that. How about educational attainment? I kind of gave this one away, didn't I? Ordinal, hopefully you're thinking we can put that in an order, still not numbers. We can't do math with it, but we can at least order it. We can structure it. Current temperature. This is the giveaway one as well a little bit. Interval level data. How about the amount of snow on the ground? Hopefully you're thinking ratio level data. This is one where we would have a zero. 0 inches of snow mean that there is no snow. So the 0 means the 0 in that situation. Satisfaction with program services. Hopefully you're thinking ordinal. Okay, so it's pretty straightforward, right? Again, the important thing is going to come next week when we talk about how this data is being analyzed when we're talking about descriptive statistics. All right, so we're concluding our walk down definition lane. The definitions are here. You have braced yourselves. Congratulations, you've made it through this first statistical talk. Again, give yourself time to integrate all of this. The important thing to know is just descriptive and inferential statistics are what we're going to be talking about this year together, this semester together. Descriptive statistics are when we're simply describing our data set. Most often we're describing a sample. Sometimes, but not often, we're describing a population. Inferential statistics are what we'll focus on in the latter half of the semester. We're going to focus on the process that's used to take a smaller sample and make broader inferences about the general population, which is how we get a heck of a lot of information in this world. Variables and constructs are what we use. Of course, how we conceptualize those, how we operationalize those, heavily dictates the results we're going to get, heavily ties into reliability and validity. Can we even trust this information at all? All of this we're going to be applying over the next semester together. Starting with descriptive statistics next week, we're going to be diving into different ways that we can describe our data set. We'll be tying back in those levels of measurement when we talk next. See you then.